Wonderful. So today we are going to talk about visualization, and also we will import some sample data, as I want to call it. Oh, you can't see the data, Julie. I will share it again. So if you bear with me 1 second. So if you please follow this link, there is a tiny sample data that I have created for the beginning of this session that we will go through. So I wanted to talk about a few issues that we had before moving on. So first of all, for those who didn't have a MATLAB license, the academic license, MATLAB staff have kindly offered to extend the trial license. So if you have any issues still, please let me know, and I can forward your email to them, and they will extend your trial. Also, we had an issue with Teams, Microsoft Teams. So unfortunately, it seems like I can't share files and videos and the resources that we are using for the sessions directly onto Microsoft Teams, because most of the attendees are from outside the University of Aberdeen, so there is a regulation, IT regulation, that I can't just go around. So I am trying to upload everything to Google Drive and share links on our meeting page. So please, every now and then, sign into your Microsoft Teams if you're not always logged in, and just follow what's happening on the page, because sporadically I will just upload stuff on. I will try to upload the sessions after the session. It takes a while for Microsoft Teams to give me the video, the recorded video, but I would upload them immediately and put a link on our chat page, and also the exercises, resources, the code that we are going to do each session. I will upload them immediately after the session and put them in the chat. So keep an eye on the chat for the session, and there are going to be stuff coming up, hopefully. And if you have any issues, please don't hesitate to email me. You can just even type your questions in the chat, or any issues that you have. One more thing to mention is that the sessions are every other week. So we don't have a session next week. It's going to be 2 weeks from now. So this is the second session. In the first session, we went through the basics of MATLAB. So we had an introduction to MATLAB. We used some built-in functions, including maximum, round, size, and other functions that are built in MATLAB. We talked about arrays, vectors, and matrices, and how we can index into these. And we completed numerous random calculations, and we did some arithmetic functions on matrices and vectors. So today we are going to go over some of this stuff. I will just have a few slides on the main things that we covered last session, sorry. And we are going to have an understanding how to use MATLAB to import data. And we're going to do more indexing. And today specifically, you're going to learn logical indexing. And then we're going to have some plotting in MATLAB, visualization, basic plotting. And we will go through a number of problems together. So next session, as I mentioned, is going to be 8th of March, not next week. So if you remember, we covered some arithmetic operators in the first session that you can use for matrices. And also, this is different for arrays. So the full list, if you type help OPS, so it's at the bottom of the slide. If you type that in MATLAB, you will have a page full of these operators. But here is a brief list of them. So we use parentheses for matrices and for indexing into matrices and stuff. We had complex conjugate or transpose. We used power. We had multiplication, and we realized that for matrices, if we want to do multiplication for every single value, we have to do dot multiply. We used left division and right division, and we realized again for arrays we need to do dot division. And we did addition and subtraction, both for matrices and for vectors. So I'm going to talk a bit briefly about data and what MATLAB data is basically. So MATLAB can work with a range of different data types. So data can be in forms of numeric data, text, images, which we are very interested in, signals, like, for example, time series data. Some people might be interested in time series. And we have different data types that we are going to work with as we go along. So these include double, string, structured tables, which is very helpful and important. And we are going to have logical, categorical types of data. If you're interested, I'm going to try to put a link here. So here is a complete list of data types in MATLAB. So let's go to MATLAB. So you can either open your MATLAB desktop software if you have it installed on your computer, or you can navigate to matlab.mathworks.com if you have a MATLAB account. I have already emailed everyone about this, so you can sign into your account and use the online platform for MATLAB. So please open your MATLAB, and I'm going to share my MATLAB screen now. So this is my MATLAB. So MATLAB has some built-in functions, that built-in data sets that everyone can use. So we are going to just input one of them. So you can type in load serial.math. And as you can see in my workspace, there is a number of variables that are loaded, and I can use them and work with them. So this is the serial data set of MATLAB. So it's a sample data set. There is a link that I can share with you. This is where you can find more data sets if you were interested in. So these are all prepared for you. You can directly import them to your MATLAB workspace and use them and do your data analysis on them. So as you can see, we have different variables. So for example, the names, you can double click on the variable in the workspace, and you have the names of these variables. So there are 77 different types of serial that are included in this data set, and you have the calories for each of these, and the carbohydrate, I don't know what these are really, fat, fiber, but you can just explore it. So for example, if you want to look at one of them, I would just type calories to see what I get. So you can see that there is a range of different numbers in the variable called calories, and each one of these rows is associated with each of those serial types. So I can just randomly use this to do random calculations. So for example, one of the operators that one of the functions that we used last time was the mean function. So I can just simply type mean and the name of the variable that I want. So here I'm typing mean calories. And this is the mean value of the 77 values that are stored in calories. And now it is stored in a new variable called ans as an answer. And you can use it, you can, as I said, find the maximum value of the calories. Among these, you can find out the standard deviation, just whatever you normally want to do with a normal numeric data set. So I'm going to clear this. And as I mentioned last session, clear clears all the variables from my workspace. So if I press enter now, everything is going to clear from my workspace and there is no variable left there. So I'm going to press enter. So everything is now gone. Now you can have a look at another one. So this is one that we are going to use in our exercises after this session. So this is a very good data set in terms of how it looks like medical data that you receive when you're collecting data, for example. So this data, I stored it in a variable called data. So if you want to assign the load function, which we are loading this data set, that's the name of the file. So I'm assigning it to a variable called data. So this is a structure, as you can see, it's a 1-by-1 structure. I just double clicked on it. And if you look at the variables inside, there is a description. So the description tells me that this is a simulated hospital data. And there is another variable inside that is called hospital. So this is a table of different variables that are stored as a variable called hospital in this structure in the data set. So as you can see, it looks very similar to what you get as a medical data. So it has the names of the participants, their gender, age, weight, whether they are smoking or not, their blood pressure, and these are trials. So you can see that some of these are missing. So it's like when you have a medical data that has missing values. And each of these patients or participants have a code assigned to them. So that's how you know who they are if you don't have their last name. So you are going to be using this in the example, in the exercise that we are going to have at the end of this session. For next session, I'm going to give you some homework basically. So I'm going to again clear my workspace. If you remember, you can use clear or you can use clear and the name of the variable, either way. So I'm going to use clear and then CLC. CLC clears my command window. So basically now I'm going to start fresh. Now, in your MATLAB, if you navigate to the folder that you downloaded, this data file that I just sent you or sent you before the session, if you navigate to that folder, we want to load this data file. So I'm going to wait a few seconds so everyone can load the data file. So we are trying to import data.math. So if you have followed the link that I sent you in the chat, it takes you to a Google Drive page and then you can download that data file directly. And then you can change your current working folder. So this is the current folder. For me, it's on desktop session 2 folder. For you, it can be your download folder. So if you navigate to where that data file is, then we can use it. So I'm going to just load the data file, and it is called data.math. If you load it, then you can see that there is a data file and it's in numeric data. It has 17 rows and 40 columns. So you can see all these values here. And I have randomly put some empty, as in none, values inside. So none means you are missing that specific type of data for that participant. So if you have a look at this now, this is my third participant, for example, if we consider each row as a participant data. So I'm missing the eighth value, the eighth variable for that participant here. And you can see randomly I have put some NaN values inside the data, so you can see them for different participants in different columns. So let's create a matrix called M1 that includes the values of rows 4 to 9 and columns 18 to 21. So I'm going to do that. I'm going to close this and create a new variable called M1. And we want to index into data. So we had this last week. So I said rows 4 to 9. So first we put 4 to 9. And then we have the columns 18 to 21. So here I'm trying to extract a portion of the data that is stored in our data file. So this portion can belong to any participant. This is just random. I chose participant 4 to 9 and can belong to any feature. So if we consider those columns and the as the features of the data, I'm choosing features 18 to 21. So if I press enter, I'm going to have a new variable. It's a 6x4 numeric data. It just has numbers inside it. If you open it, you can see that there is no variable missing, and these are just random numbers between 0 and I think the maximum is 250. So yeah, 225, yeah, 0.25. And so these are just random values that I have chosen from this data set. Let's create another matrix called M2 that includes the values of rows 12 to the end and columns 30 to 33. So M2, it includes the rows 12 to the last row, which we discussed. You can use end, and MATLAB automatically recognizes what row you're referring to, and columns 30 to 33. So if I put semicolon now, obviously I'm not going to see M2 on my screen. If I don't put semicolon, MATLAB in the command window is going to show me what values I have for M2. So now let's again index into data. As you can see, these are both the same size. I chose them to be 6x4. You will know why. So let's create a vector this time of all the values in the 8th row of data. So I'm going to call this V1, and I'm going to have all the values of the 8th row. So if you want to have all the columns, instead of assigning numbers to the columns, if we want all of them, we just put the colon sign there. And I have specified that I want all the columns of the 8th row. And I'm storing that as a variable called V1. Now, this is a vector, so if I open it, you can see that it's a 1 by 40 because we have 40 rows. It's a 1 by 40 vector, so it's a row vector. It has only one row. Now, imagine that you are working with all these variables and you have done numerous calculations on them. For example, you can find out what the mean value is for certain columns of these variables. And you want to store all these variables in your workspace as a file and use it later. So in order to use in order to save your workspace, you can use the function called save, and then you can just give it a file, file name. So for example, I'm calling it data file, and the type of the files that are stored, just like you saw, the file that you downloaded was called data.mat. So MATLAB stores the variables in the workspace as mat files, so .mat files. So I'm just giving it a name. So I'm saying just save all my workspace variables as a file called datafile.mat. Now, if I press enter, here in the current folder, you can see that I have a new file added to my current folder, and it is called datafile.mat. If you open it, MATLAB automatically loads the data into your workspace. So this is basically what you can see. If you just click on it, you can see an overview of what is inside it in this little window on the left-hand side. So for example, data was this, 17 by 40. Data file is just a bigger, a larger number of variables that you can see we had it in workspace, and now we saved it as a file. So we had a variable called v1. Now you can see the values of v1. As again, I said, it ranges from 0 to whatever. Now let's find out if we can see if there is a number, if there is a value more than 0.5 in these. So just a random number. I'm just trying to see if there is a variable, there is a value more than 0.5 in v1. So all I need to do is saying, just find whatever value in v1 that is more than 0.5. So if I press enter, the answer, the result, is a logical variable, as you can see here, the answer. It's a logical variable. Logical means it's 0 or 1. So if that condition is true, the value is 1. If the condition is 0, the value is 0. So as you can see, there are multiple values that were more than 0.5, and for those we have 1s. And for those that were less than 0.5, we have 0s. So you can just compare, simply compare between these, column 1, and see that, for example, this one was more than 0.5, so we have a 1 for it. The third value was more than 0.5. The fourth value wasn't, so we have 0 for it. So this is called logical indexing. We are telling MATLAB that there is this condition, and we want to index into our vector based on that condition. Now, how do we know what these values are? So we don't always have, for example, v1 here in front of us to compare and see what these values are. If you want to find out what these values are, all you need to do is say, we want the variables in v1 that have that condition. So this is basically my condition inside of parentheses. And I'm saying, find the values in v1 that are based on this condition in the parentheses. So if I press enter now, I will have all the values inside v1 that were more than 0.5. So this is called logical indexing. We are trying to find out what variables are following a certain logical condition. So this is very important and very useful. So how about, for example, if you wanted to assign a value to these? So for example, we want all those values that are less than 0.5 to be simply 0. We don't care about them, we just want them to be 0. So for that, we just simply type all the values in v1 that are less than 0.5, and we assign those values the number 0. So this is now going to put 0 instead of all those values that were less than 0.5 inside V1. You're going to have a look at that. So anything that was less than 0.5 is now replaced by 0. So this is assigning a value to those values that we didn't care about, that were not complying with our condition. So another very useful function, now that we are on logical indexing, there are multiple of them. One of them, as I mentioned, was that we had so many empty items inside data. So data, as you looked at it, I'm going to open it again. So it had so many nan options. Nan means it's not a number, it's not acceptable, we can't work with it. So there are multiple of them, and we don't know where they are. They're just randomly assigned, as you can see. And we want to just do something about it. So we want to see, for example, here in V1, whether there is a nan option or not. So MATLAB has a very useful function, built-in function, which is called isNan. So we are going to find out whether there are any nan values inside V1. So we just type isNan in brackets V1, which is following what we discussed last session. So we have the function name, and then inside the parentheses, we have the inputs. So here I have one input, which is my variable V1. And if I press enter now, I will see whether I have any nan values or not. So here I can see that no, none of these are nan. If there was a nan value, I would have a 1, because this is a logical statement. Is it a nan or not? And if it is a 0, it's simply not a nan. So how do we find out, for example, if we had M1, let's see, is there a nan value in M1? So here is nothing. Let's go to data, because we know in data there is some. But data is so large, so it's a 17 by 40 variable in terms of its size. How are we going to find out where these nan values are? So as you can see, some of these are 1. So these are where MATLAB has found the nan values. So how many are they? We simply can use the function sum to find out how many nan values we have in data. So this is our condition. You can copy it. And I'm saying just add up all these values based on this condition. So it's going to go through the 17 rows and 40 columns, and it's going to just add up all the numbers inside. This is just to find out how many nan values we have randomly. Okay. So as you can see, it is giving me this. What does it mean? Can anyone volunteer? We have an answer that is 1 by 40. So we have 40 columns of just one row. No volunteers.
It's giving you an answer by columns.
Wonderful. It is telling us how many nan values are in each column. And that's why we have 40 columns. Great. Let's move back to our slides. So what did we learn? So we realized that there are certain functions that you can use to import your data into MATLAB. So we are going to use these later, but just to touch on them, we use load for now because we had .math files. Later on, you can see that for any file that you can open with Excel, so XLX files or XLXS files or CSV files, which are typical for data files or text files. You can use read table. And for images, which we are going to do in exercises, you can use imread, image read. And there are, again, several ways of saving our workspace, our data, whatever we have, whatever variable we have worked on, as a file, and export it and save it and have it later on. So tables in MATLAB can contain different data types inside. We realized that. So the hospital variable, the hospital data, was a table inside it, and it had different data types. So it had names, it had numeric values inside it. We are going to do table indexing, but just to let you know, we are going to do dot notation for that. But we are going to expand on this later. And you can use indexing to select a portion of your data. So that's what we did to extract M1 and M2. And we realized that logical indexing is wonderful, and we can choose subsets of our data when we have these conditions. And obviously, you can use multiple conditions using Boolean operators. What are Boolean operators? So here are a few. So this is equal to. We used greater than and less than. Greater than or equal to, simply that. Less than or equal to, not, and or. We used isNaN, but for example, if we had an empty value inside the matrix, you can use isEmpty. So hospital had empty values in the trial column. And we have any and all. Again, these are very useful. So any is true if any of the elements is non-zero, and all is true if all the elements are non-zero in a matrix. We have previously used zeros and ones as useful built-in functions. So zeros simply creates an m by n matrix of zeros. So you just specify how many rows and how many columns of zeros you want. And if you have previously used a matrix called A, you can just create a new matrix of zeros with the size of A. Just you can simply use zeros in parentheses size of A. And that will create a matrix of zeros that has the size of the matrix A. Let's go back to MATLAB and do some more coding together. Good. So let's create, I'm going to close data. We don't need that. Let's create a new variable called x that has the values of 1 to 10. Just simply 10 numbers from 1 to 10. So x, as you can see, is now a row vector of 10 numbers, just 10, 1 to 10, stepping one at a time. So in order to use the operands, I'm going to use the array power. So let's create a variable called y that is using array power to take each element of x to the power of 0.5. So we want to put each element of x to the power of 0.5. So we simply, as I mentioned a few slides ago, so this is in order to use each element of the array inside x. And I'm storing the output into y. I'm assigning these values to y. So, sorry, I chose y there. I need to enter that. Okay, so as you can see, this is each value inside x to the power of 0.5. So these are the values. Now, create a condition for any x equal or greater than 5 and call it I1. So we are creating a condition for any element in X that is equal or greater than 5. So this is the condition. So this is the logical indexing we want to do. So this is telling us that if there is any value in X that is more than or equal to 5, choose that and put that inside a new variable called I1. So obviously this is going to do that. Sorry, again, I chose the condition. Yeah, so now I1 is formed. And then I'm going to create a condition for any y smaller than 3 and call it I2. So I'm going to say I2 is any y that is smaller than 3. So as you can see, again, we have logical indexing, and it's telling us which elements in y are less than 3. Now we want to combine these two logical conditions and create a new condition. So I'm going to create a new condition called II. I'm going to say if both of these are true at the same time, we have a new condition called II. So II is using an AND operand. So if you remember in the slides, I said AND is one of the logical things that we can use. So AND is telling us if I1 and I2 are both true at the same time, then we can have a new condition called II. So this is II. I'm going to put semicolon, but you can obviously explore what II is. And if I put that without, you can see that there are some values that are still 1 here, and the rest are 0. So these are where II is true. So we are going to locate those, but there is a function that does that for us. So if you enter find and put your condition as an input to this built-in wonderful function called find, then it tells you the location of those values that are following these two conditions at the same time. So it is telling us that the location is 5, 6, 7, and 8. So exactly as you saw here, it's telling us where these are. So find is another very useful built-in function. So let's move to plotting. This is something I wanted to cover last session, but unfortunately there was no time. So we are going to start very basic. So plot is a built-in function by MATLAB. As you can see, you can use different combinations of inputs for plot. But for now, we're just going to plot one of our variables in our workspace. So for example, I'm just going to choose X, and I'm going to plot X. So as I mentioned, when you have a function, the inputs go inside the parentheses, and then you just use the function, press enter. And yes, there is now a new window that is in front of you, hopefully, and that is called Figure 1. So this is the name of the window, and that's the plot. So we had numbers from 1 to 10, and since there is no second input, we are going to use more than one input later on. It is just simply putting 1 to 10 in terms of their order against their order and plotting it for us. So this is the simplest use of function plot that you can have. So let's now plot y against x. So this is a term that is very sensitive to you. So we want x to be on the x-axis and y to be on the y-axis. So we have x here and y here. So both of them are of the same size because we define them like that. So y is the values of x to the power of 0.5, each value, each element to the power of 0.5. So I'm just going to plot y against x. And the plot is now like this. So as you can see, we have x on the x-axis, so 1 to 10, and the values of y, the equivalent value, the corresponding values of y. So if it is the first value in x, which is 1, we have the corresponding value in y, and the second value, we have the corresponding value in y, third up to the 10th value, and they are plotted against each other. So plot is very useful and very vast. So at the moment, if you just specify that you want to plot two variables against each other, it just gives you a line plot, what we call a line plot, and the basic color is blue. So I'm going to close this. Let's change our plot into a circle plot. So for example, I'm plotting x and y again, but instead of a line, I want blue circles. I'm going to go through these in a bit, but I'm just entering it for you now to see what happens. So if you plot that, now instead of the line, we have the corresponding values as blue circles. So these is just because of this. So we specified we want blue circles. So B stands for the color, and the O stands for the circle. So you just enter the O inside the single quotation mark. And excuse me. And your plot, instead of the line plot, is going to be these tiny blue circles. So let's now plot something else. So we had the condition II. So we want to now plot the II members of x and y as red circles. So we want to index, logical index into x and y, plot them against each other, and instead of these blue circles, we use red circles. So how do we do that? So simply you use the function plot, index into x. We said that the condition is II, simply inside of brackets II, and inside of parentheses II for y. So we are saying all the values inside x that comply with II, all the values inside y that follow the II condition. And it's going to choose those, and we want them to be red circles this time. So you plot them against each other, and as you can see, there are 4 values that are plotted here. So if you remember II, the location of II, the ones were in 5, 6, 7, and 8. So it is you choosing the elements of x that are in those locations. So the 5th element, 6th element, 7th element, and the 8th element of x, and also the corresponding elements in y, and it's plotting them against each other, and you are specifying that you want red circles in those elements. So let's move to something else. So what if you want to plot something in a new figure? Because each time I was just closing this and it was just plotting things in figure 1. Even if you don't close it, each time this plot is going to replace, this figure 1 is going to be replaced by a new figure, as you realize by entering it. So if you want a new figure, I'm going to keep this in this corner so you can see that it is still open. You just simply tell MATLAB that I want a new figure. So you just type figure. Figure opens a new window for you. So it's empty. We haven't plotted anything on it as yet. And it is called figure 2 now. So we have our figure 1 open, and now we have figure 2. This is to just have multiple figures on your window in case you need it. You want to compare something against something else. So we are now going to use figure 2, where we keep our figure 1 untouched. So I want to plot X and Y in blue circles on that. So again, what we had before, you can just simply use up arrow and go through your history of commands and choose that command that we did. So we are going to choose this. Now this is going to be plotted on figure 2. What if you want to plot multiple things in just one plot? So forget about figure 1 now. What if we want to plot something else on top of figure 2? So MATLAB has a function called hold. So it's simply going to hold my figure, and you just tell it whether you want to have the hold on. So you activate the function hold, so it is going to keep that figure untouched, and then you can plot things on top of it, over it. And whenever you don't need it, you just say hold off. So I'm going to have hold on. Sorry, that's close. And going to plot what I had before. You can just simply plot the X and Y that follow the condition II in red circles. So let's see what happens. So I am holding figure 2, and I'm going to do a new plot over it. So the way it's going to look like is this. So we had figure 2 as these little blue circles, and there were 10 of them. And as you can remember, we had 4 red circles for the II condition in X and Y that were plotted against each other. Now I'm putting these over my previous plot, which was just simply Y against X. And as you can see, all these values are in corresponding places, but they are red this time because we have specified that we want them to be red. So hold is a very important function if you want to plot 2 different things on top of each other. You just say, hold this figure, I want to do more with this figure, and then you just plot whatever you want. So, for example, you want to do that. Another shape is this star. You say R star, and it is still going to put the plot. Oh, we are back to figure 1. Yeah, because I chose figure 1. Okay. It is going to change the plot on that. Back to our slides. So what did we learn here? So we learned that find is very useful when we want to do logical indexing, and it's going to tell us the location of the values that we are looking for inside our variables. And then we use plot, the function plot, in order to create figures. By default, as we realized, plot is going to replace the previous figures, and in order to stop that, you can use the function called figure to create a new figure, or use hold on to just keep the current plotting axes on hold, and then plot new graphs over the current figure. And you can have a look at the documentation for hold. You can simply type doc space hold in your MATLAB, and you can have a look at that. Also, yes, we talked about figure. So figure creates new figure windows. Plot X plots a line graph of X versus the index number of the arrays that we have. So for example, when we plotted X, which was number of 1 to 10, it was plotting X against the order of these. Plotting X and Y plots the line graph of X versus Y. And we realized that there is a range of different strings that we can use to change the shape of our plot. So for example, this is just R dash dash. And for colors, we have red, green, blue, as you saw. And we can have dashed lines or circles or solid lines or stars, as you saw. So summary of them are here. So some of the plot properties, as you can see, the colors are these, so red, green, blue, black, yellow, cyan, magenta, and white. I had to use a black background to show white. And the markers are completely, like, there's a massive range of them. We are going to use some of these later on. And if you want lines, there are 4 different types of lines that you can use as well. So we are going to have color inputted in plot. So if you look at the documentation for the function plot, you can see that MATLAB follows the American spelling of color. So you can specify, I want to change color to this certain color, and you have to remember that this is following American spelling. Now let's move back to MATLAB and do some more stuff. Any questions so far? There is a noise. Yes, sorry, as I mentioned, this is the fan. I have ordered new earphones which just arrived in post. It was a bit late for the session, but I'm going to use those hopefully as noise cancellation. But yeah, I can't help the noise. Any questions about what we have covered so far? No questions. Am I going too fast? Because we had a comment, point of suggestion that I'm potentially going through stuff a bit fast. If I am fast, please tell me and I will slow down a bit. So no questions, so I assume that everyone is doing okay. So let's plot a few independent plots in one figure. So how do we do that? You have seen these fancy images in papers sometimes, that there are like multiple plots in one image, and then there's A, B, C, and they are explaining what these are. So how do we do that if you want to have multiple graphs in just one figure? So MATLAB has a function called subplot. So subplot is written like this. Basically has M, N, and T, as you can see, as input. So M is the number of rows of graphs that you want to have, and N is the number of columns of graphs that you want to have. And P is the place, the location of each plot that you are referring to. So for example, if I want a graph, a figure that has 2 rows and 3 columns, so I want 6 different figures in one, 6 different graphs in one figure. All I need to do is saying I want 2 rows, 3 columns, and now I'm going to plot my first plot. So this is, and this one is referring to the place of the figure, the image that you want to plot right now. So if you do that, MATLAB is going to open a new window. So it has room for 2 rows and 3 columns. You can't see them because we haven't specified anything about them. And at the moment, we are working on the first graph. So let's plot V1 on that. So we had a variable in our workspace called V1 here. It was a vector, and we are going to plot V1. As you can see, V1 looks like a time series data. It's just random numbers, 14 numbers. And now, since we specified we want it to be in the first place, it is now plotted in the other figure as the first graph. Now, if we want to continue, we can continue with, for example, plotting y against x. So subplot again. This time we want to use the third position. So we will say the previous size that we had, but the third position. So MATLAB is going to be ready for the third position graph to be inputted by us. So we are going to plot y against x, just what we did before. And we are going to do red circles. This time I'm going to specify the line width. I will explain what that is. Sorry, small line, capital. And I want it to be size 2. So line width is telling MATLAB that we want the plot to have this property, and we want that to have the size of 3. Let's see what happens. So as you can see, I will make this a bit bigger, and hopefully you can see it better a bit. Good. So this is now the third place, as we specified we want our plot to be. And we are plotting y against x, as we had in our workspace, but we specified that we want them to look a bit thicker, but we don't have any lines. But yeah, it is still changing the shape of the circles for us. So let's now plot something else. So let's try to plot M1 in the 4th position. So I'm specifying I want it to be the 4th position. I can type in one line if I use the semicolon. We did that last session as well. So plot M1 in the 4th position of our 6 plot figures. So the way it is going to count it is that this is place 1, place 2, which is empty. We haven't specified anything to be plotted there. This is the 3rd place. This is now the 4th place. And now it has done M1. It has plotted M1 for us. So this is M1, and that's the way it looks like. So it is a number of colors, number of lines in different colors. Likewise, if you want to plot, for example, something in place 5, and as you can see, we have a variable called ans. This is 5, 6, 7, 8. So I just want to plot that in the 5th position. So I'm expecting something to come here because, as I said, 1, 2, 3, 4, 5, 6. This is the way it's going to go through the plots. And this is it. So it's a line 5, 6, 7, 8. It's just going up in numbers, and this is the order of them. And this is just plotting ants. So let's plot I1 in the last position. So we had a condition I1, and we want it to be in the last place. So that's the 6th place. So as you can see, there is a blue line that is going from 0 to 4, all zeros, then goes to 1s, up to the number 10, the index 10. So this is plotting multiple things, multiple graphs in one figure. So there is a lot to do with plotting, but we are just touching on it. So let's go back to our slide. As I said, we have the subplot function. So these are, this is the way it's going to be. So subplot is the name of the function. The inputs are the number of rows, the number of columns, and P for place. So for example, as you saw, we have 3, 2, 1. So this is going to be, sorry, this is wrong because it should be 2, 3. We have 2 rows, not 3. I will fix that. So this is the place 1 as we have specified here, place 2, place 3. 5th place is going to be here, as you saw in the example. So let's go to MATLAB again. Now, imagine you have multiple figures open, multiple figure windows open. How do we close those? So we know how to clear our workspace. We know how to clear our command windows. So that's CLC and clear function. If you want to close the images, you just simply type close all. And as you can see, there was a figure here that is not closed. So all your figures are going to be closed now. So let's plot x against y again, but this time we use red stars and a line. So I'm going to find x and y in my history, red stars and a line. So that's how you specify you want to plot y against x, and you want to have red stars and a line. So if we plot that, it is going to have red stars for the corresponding numbers in the x and y, and you have a red line connecting them as well. Now, one very good practice when you have a figure, obviously, as you know, is to have legends, labels for x and y axes, title. So these are things that you can add to your figure before you save it. So here, if I want to save it, I'll just put save as and just save that image, but it is not very informative. So you want more information on the figure before you save it, rather than just photoshopping things on it or typing things on it. So for example, if you want the labels for x, MATLAB has a built-in function called xlabel. So you just simply type xlabel, and as you can see, your input can be text. So single quotation, and I'm going to put label for x and press enter. As you can see, the text that I had in as an input to xlabel function is now written for my x axis. Likewise for y, you can use single quote or double quote. Both of them should work. So this is label for y, label for x, because it's just a normal string. So both of these should do. And for title of your image, so you can just simply type title. This is the title for this figure. And you can literally type anything. And the title comes here, it's bolded, so it is obvious, it's on top. And that's the title of your image. And then, for example, you can hold it. Let's hold it and plot M1 on top of it in blue right shifted triangle. So let's try that. So you just simply say hold on to hold that figure. And we want to plot I1 in blue right shifted triangles and lines. Let's see how that looks like. So that's I1 that is plotted in the same plot as we had x and y against each other. So as you can see, I used greater than sign, and now it has given me these right shifted triangles. And now that I have two lines and two different colors in one image, it is very useful for me to know which is which. So that's how you use legends. So you use the function called legends to have legends for your plots. So the first plot, you have to follow the order and the way you did the plot. So first we plotted y against x. So the first legend has to be y against x, the one that is related to the first plot. The second one is your second plot. So I just simply say the second one was I1. And what happens is that MATLAB is going to add a legend here to my figure, which specifies what this line is. So this is y against x. So it's giving me more information about what is in this figure. And these blue lines and right shifted triangles are I1. Yeah, you can do several things. You can move this around, just click on it and drag it around. You can just put it where you think is best and then export your figure and save it. So what else do we have? So what did we cover? We covered X label, Y label, and title. So as you realize, you just need the text to specify what these different properties of your plot are, but you can use doc space plot to see more information. And obviously, you can enter legends for the lines or symbols that you have added to your plot. So, as I said, all you need to do is just to keep the order of what you plotted in the figure. And so long as you do that, everything is fine. Any questions so far? How are we doing? Okay, I think it's a good time for us to have a little break. Let's say it's 12 minutes past 3. Shall we have a break until 25 past or half past? And I'm here to answer questions. Yep, 25 past it is. We will start at 25 past. So yes, how to save just one variable but not the whole workspace in a current folder. Great. So yes, the way you do it is to save, use the same function and file name and then the name of the variable. So that should do it. So if you have just multiple variables in your workspace, you just want one of them to be saved as a math file. So you just say, I'm just typing an example .math and just your variable that is called A. So I'm saying the name of the variable should be variable A.math, and then you put the assigned name of the variable, which is A, and that saves that certain a variable from your workspace into a math file in your current folder. Good, so it's 25 past. So I'm going to talk to you about scripts and functions, if I can share my screen. Great, okay. So if you have used the chat section of the session, I uploaded the material from the first session as a Google folder with you, and I shared it with you. So there was a file that was a live script called session1.mlx. So I can just copy that link and share it again potentially for those who don't have. Oops. Copy and paste. Good. So this is the link to all the commands that we went through last session. So as you can see, we type so many things in the command window, but what if we actually want to use these later? What do we do so we don't like lose all our code? Because next time you open MATLAB, it just opens a clear screen and there are no variables and there is no file open, there's nothing there. So each time you open MATLAB, you have basically lost whatever you have done previously. So in order to do that, you can simply have a script, a blank script. And if you click on that, it opens a new window on MATLAB layout. And okay, I will try that in a second. Let me explain this, and I will try the save option in a second. So if you open a new script, then you basically can type your commands here as well. So for example, we had specified what x was. So x was 1 to 10. And then we had y, which was x, each element of x to the power of 0.5, for example. And like exactly the way that you were entering commands in the command window, you can put semicolons in your script or not. And then basically you can save this as a file. So the way MATLAB saves the files is going to be a .m file. So if you press save now, so as you can see, it is not saved yet. So it has a star here. So if you save it, it is going to suggest a .m untitled .m file. So you can just call it commands session 2. You have to remember that it has to be a standard naming. You can't use certain characters on your keyboard. So it follows the rules of naming files for program. So this is going to be a .m file, and you can just, oh, the link is not working, sorry. I will try that. You should be able to access the link if you go higher up in the chat that we have in the session. But if it doesn't work, I will try that again and send the link again. So we don't need to use that. I'm just explaining the scripts for you. So that was just one example script that you had saved for you, and it had all the commands in it from the previous session. So this is what we are going to save for this session. So for example, we had these two commands for X and Y, and you can simply save it. So if you can see now, there is a .m file that is the file that we have for this script. So if I close it, you can just open it and use it later, and it still has all the commands that I entered. So this is extremely useful. Yes, that's the problem with Microsoft and University of Aberdeen. I will put them all on Google Drive and share that. So this is extremely useful for using your commands later on. We all need our codes. We all need our functions that we have written to be used later. We don't just do a task once. We need to use them later. So in order to do that, you simply save your scripts. It can be a live script. So if you press new, there is an option of live script here. There is a function option, live function, class, system object. So we will go through these later on, but live script is very similar to script. So the one I shared previously is a live script. So the format, the name of file is going to be mlx instead of .m. And the way it works is that you can, as you're typing your command, you can actually see the output as you're typing. So basically, if I copy these and just have them as a live script, you can simply just press run, and you can, my computer shows them, see the output somewhere. Oh, we haven't saved this, sorry. You need to save the script first, so save as. And I'm going to call it live session 2. And then you can simply choose the selection and run it, or just press run. And it runs because I'm putting semicolons. I can't see the outputs now, I realize. So it shows you the outputs as you are working through your code. And it's very useful to begin coding in the form of a script writing. So you don't need to directly start writing a script if you're like not sure of how it works. You can simply use a live script, see the outputs as you're typing, and just move with your script to make sure everything is working. So this is extremely useful. So for example, the session 1, I will just show you, I will share this again with everyone. I will show you how it looks like. So I have input explanation. So this is the title. You can simply treat it as a Word document. So it has all these different like settings for editing your text. And it has a code option that you can put your code in. And as you can see, you see the outputs as I'm going down the lines. So this is very handy and useful for coding, and you can see all your outputs. So this is literally everything from session 1. I'm going to share it again, as I mentioned, and I'm going to share a similar file for session 2. So this is about scripts. Now, I want to give you one exercise that in the time that we have less than half an hour. Hopefully we will manage to go through that. So bear with me as I copy the exercise for you. I will copy it in the chat section, what I want us to do. and then we can code it together. I will give you some time to think about it, of course. It's a very simple exercise that involves the things that we did today. So it has some indexing, some plotting, and then there is more for you to do for next session. So this is the exercise. I think we can do this in, let's say, 15 minutes, and then I'll go through the answers with you. So 15 minutes, let's do this. Thank you, George, correcting. Yes, it needed, yeah. A is also a string, that's correct, yes. Yeah, no more questions. So let's do this exercise together. So we want to clear our workspace of any variables that we had previously. So that's simply putting clear. And please write your answers as a script. So try to have it as a script, either live or just normal script. The exercise is in the chat area. So if you open the chat area, you see the exercise anchor. I can copy it and show it on the screen as well, if that helps. So bear with me a second, I will copy that over. It cuts some of the exercise on the web. I think I can scroll down and you can still see everything. So this is the exercise, and then I'm going to fill in the gaps with the code. Okay, I shared a link for a Google Drive folder that has all the material for session 1. You can, I think, download that if you don't have any issues with Google Drive in your institute. Sometimes they don't allow downloading from Google Drive, but I hope it's okay. If you can't access them, let me know and I will find a way. So I wrote 2 lines of the script, the answers to the exercise. Let's carry on. So before that, is anyone willing to share the plot, the final plot that they have? If not, it's okay. Has personal information anyway, but yeah. If anyone is willing to share their screen, let me know and you can do that. I would stop sharing mine.
I could share one if you want.
Wonderful. Go ahead, Peter. Thank you.
Hang on, how do I actually do this? There you go.
That's it. That's exactly more or less how it should look like. Wonderful. Thank you. So let's code this together. I'll share my screen again. Good. And you should be able to see my screen. Yes, okay. So initially I cleared the screen. So if you want to run it, you can simply choose it and run it. And it clears all the workspace. So we have a variable called this year that is equal to the current year, which is 2021. And you need to create a vector that is called years. And that's going to be from year 1900 to this year. So you can either put 2021 or just use this variable that we had. It is okay. Sometimes people use the square brackets around. Sorry. It is okay. It's the same thing, but you can just omit them because you're just stepping one at a time. And it's just a range, so you're specifying a range of numbers, so it is okay. So enter, create a variable called b, which is equal to the year that you were born. So I'm going to do that. And create a logical index into the array years for the years since you were born. So how do we do that? So we want to create a condition that is basically going to be from the year that I was born up to now. So it's going to index into years. So years included 1900 up to 2021, which is now, and it's going to be greater or equal to when I was born, which is B. Great. Now we want to create an array the same size as years containing your age in each year and zeros for before you were born. So it is easier if I create an array that is just zeros first and then replace what I want with the number of years that I was born in. So I'm going to create an array called age. So it is going to be zeros of size, as I mentioned. It has to be the same size as years. So that's my years. And then with the indexing, so I have the condition. I want to say it is going to be years II minus my age, my date, year of birth, so minus B. And yeah, now plot your age against the years as blue circles. How do we do that? So I want to plot my age against the years. So years is X, age, and blue circles. So that's going to be the way we plot it. Now this final part is interesting. So that's again, another logical indexing. So it's saying create an index for the years you were born, you were an undergraduate, and overplot your age in red triangles for those years. So how do we do that? We need a condition. We need to say, for example, I was an undergraduate between the years. I actually don't remember. But let's say, for example, 2008, and before I finished less than equal to, let's say, 4 years later, 2012. I have no idea, but let's do that. So that's the condition. And now we want to plot this on top of our previous plot. So we need to have, hold on. First of all, you can play to see how our plot looks like. So if you play, it saves the file automatically and tries to run everything. So as you can see, line by line, because it is a live script, we are seeing the outputs. I can't actually see the plot if it is plotting anything, but I think, yes, that's it. That's the plot. You can see it now. Good. So this is what we have as blue circles. Everything looks fine so far. Now we want to plot. I'll close it again a bit. So create an index for the years you were born, you were an undergraduate, and overplot your age in red triangles for those years. So I want to overplot years undergraduate and age undergraduate as red triangles. How do we do triangles? Let's do these triangles. Great. So I will run that again. And as you can see, this is the final plot, and I have these red triangles for the 4 years or 5 years of my undergrad. It includes the first number as well, plotted against the year that I was born up to this year, basically. So this is an example of how you can use all these logical indexing and these conditions per se in order to extract certain portions of your variables of your data and use those in different functions and actually plot them. Any questions about this? I'm hoping that everyone had the right answer, similar looking plots at least. Maybe a bit younger, but yeah, similar. Any questions on this? Again, I'm going to send you the answers to this exercise as well. So if you don't have any questions, I think that was it for me. So for further exercise, there is, I suggested that you use MATLAB on-ramp course. So for those of you who haven't been with us in session 1, MATLAB has certain courses in MATLAB Academia website. So it's matlabacademia.mathworks.com. And if you have a license, you can access all the different courses that they have. But if you don't, you can still access the on-ramp courses that are available for free. And it's a very good way of going through what we have covered in the first 2 sessions. So now you can proceed up to section 13, and we are going to cover the rest of them in the following sessions. But up to section 13, everything is basically familiar to you, hopefully. One of the exercises that I wanted to do for next week is actually the project section 10. So in section 10, there is a project. We are going to cover that in the beginning of next session. But I wanted you to do that before the next session. And there is, again, another MATLAB file that I'm going to send you as an exercise, hopefully by the end of today. And I'm going to upload them to the Google Drive folder. And I want you to complete that exercise as well. And that's it, I think, for this session. Any questions again? As I mentioned, I was in touch with both IT services at the University of Aberdeen and Microsoft to solve the issue of changing the way we can share files in the chat folder. I will explain sorry, that was not supposed to be so hard because we had covered most of them. But yeah, I will explain the exercise in the beginning of next session as well. And we will go through everything line by line, and hopefully everything will be covered. Yes, that is correct as well. We can calculate age like that, but we could use the conditions and the variables that we had to calculate age. But I will definitely cover this, and we will go through it next session, the beginning of next session. But this is just an example. Obviously, we are here to learn, all of us. So please go through MATLAB on ramp, even start doing the fundamental courses, MATLAB fundamentals. And there are a lot of stuff that you will learn as you're doing it. And please code in MATLAB, start coding in MATLAB. This is the only way that you will learn if you have never used MATLAB before. You're not going to learn MATLAB completely in these sessions in this course. I'm just touching on things. I'm just sort of guiding you through. But definitely by programming, you will learn, and you have to practice. So please do the exercises as I mentioned, and I will see you in 2 weeks' time, and I'm available for questions. Email me questions or just put it in the chat and I will get back to you. And thank you very much for joining us. And next session is 8th of March, Monday, same time, 2 to 4. And enjoy your time until then. Thank you. Yes, please go through the tutorials and the courses, online courses. They are wonderful. I learned a lot from them myself. Thank you. Thanks.